Hello everyone and welcome to the introduction to ions. Okay, what is an ion? Well, an ion is what results when a neutral atom has either lost or gained electrons. And that ion is going to be charged because no longer do the protons, which are positively charged, get balanced out by the electrons, which are negatively charged. So let's write that up on the board. Right, an ion is what happens when a neutral atom has lost or gained electrons. Remembering that electrons have a negative charge, right? So we're going to write this up here too. Charged. Because now the protons in the nucleus are not equal to the number of electrons in the orbitals. All right, so let's talk about the periodic table and what happens when metals and nonmetals become ions. A different thing happens for metals than nonmetals. Remembering that metals are on the left-hand side of the periodic table and nonmetals are on the right-hand corner, top corner of the periodic table. So the metals, what happens to them is they lose electrons, okay? And the nonmetals gain electrons. That's just the way it is. So let's write that up on the board. Metals lose electrons. And when they lose electrons, they become ions, and we call these ions cations. Nonmetals tend to gain electrons. And when they gain electrons, they become anions. All right, what charge does a cation have in general? Let's think about it. If something is losing an electron, it's losing a negative charge, so that's right. It's going to have a positive charge because it has lost a negative electron. Conversely, if a nonmetal gains an electron, when it becomes an anion, it's going to have a negative charge because it has gained a negatively charged electron. Okay? So, we'll talk about how many they lose, how many they gain, the nonmetals and the metals. Okay? So, atoms tend to lose or gain electrons until the closest noble gas electron configuration is reached. Okay, and this is because any more or less electrons being lost or gained would be less favorable energetically. It's all about the energy. So I want to emphasize that electrons don't gain or lose, that atoms don't gain or lose electrons to become like noble gases, right? It's not as if it's automatically more energetically favorable to have that electron configuration of a noble gas, and so they do it automatically. It's not like that. It actually requires energy to remove or add electrons into the orbitals of an atom. Okay, so it's just that any more or less than the closest noble gas electron configuration would be less favorable energetically. And you'll learn more about that in future chemistry classes. So we'll write that note up here, because any more or less electrons being lost or gained would be less favorable energetically. Meaning the energy that would be required to do more or less would just be way too great. Okay, let's take a look at what we mean by this, loss or gain. We'll look at lithium first. So lithium, for example, when it becomes an ion, is it going to lose or gain electrons? Take out your periodic table and figure out if lithium is going to lose or gain an electron. Well, that's right. It's a metal, right? So that means it's going to lose an electron. And so when it does, we'll write this up here, losing one electron, meaning minus one electron, subtracting one electron, right? We're going to write lithium ion, it's now called, with a +1 charge. It has a +1 charge, we just don't write the 1 next to it anywhere by convention. This is called lithium ion. When we write out the electron configuration, we can see what we were talking about over here, where 1s2, right? It's got 3 electrons, so 2 are in the 1s orbital, and 1, that third electron, is in the 2s orbital, right? When it loses an electron, it's going to lose the outer valence electron, and what's left over? Just a 1s2, right? So this happens to be the electron configuration of which noble gas? Can you check out your periodic table? Which noble gas has 2 electrons? That's right. It is neon. Gosh, I mean helium. Pardon me. Okay, so let's take a look at what happens, for example, when nitrogen becomes an ion. And actually, let me back up, and I want to clarify something. So remember last week we learned about the valence electrons, and we learned how to spot them and how to figure out where they were, right? They're in the outer shell, right? The outer largest n number shell, right? That's because they are the most loosely held in the atom, right? They're the furthest from the nucleus, and so they are the ones that are easiest to remove for metals, or electrons tend to be added to the outer shells when they gain, right? When nonmetals gain electrons, because it's easiest to add electrons further from the nucleus where there's more room. Okay, so looking at nitrogen, another example, right? When nitrogen becomes an ion, does it lose or gain electrons? Can you check it out on your periodic table? That's right. Nitrogen is a non-metal, right? So that means that it's going to gain electrons. When nitrogen gains electrons, it gains 3 electrons, in fact. And so we are going to write its charge as what? 3 minus. Right? It now has 3 extra electrons in the valence shell, and so the protons are no longer balanced. There's a surplus of electrons, and there's a surplus of 3 of them, so it's got a 3 minus charge. We call this nitride, Nitride. Okay, so the electron configurations, let's illustrate this. 1s2, 2s2. Nitrogen has 7 electrons, right? So 2, 4, and then the other 3 electrons go into the 2p orbital, right? So when nitrogen gains 3 electrons, they go into the 2p orbitals as well, right? So now it's 1s2, 2s2, 2p6, right? That is the electron configuration of which noble gas? Which noble gas has 8 electrons? That's right. It is now neon. And one more thing about this reaching the electron configuration of a noble gas, no more or no less, for elements that are in period 2 and below, right, that are in the p block, right, they're going to obtain an octet in the valence shell. We call that an octet because there is now 8 electrons in the outer shell, right? This shell, this valence shell, has an n, a principal quantum number of 2, and there are now 8 electrons in there. So we're going to say that this now has an octet of electrons in the valence shell. Okay, that means that it's a full shell, right? A full valence shell. Okay, because the p subshell can hold 6 electrons and the s subshell can hold 2, right? Okay, so there's a way by looking at the periodic table, right? Another thing that we can learn from the periodic table on how to figure out just how many electrons are lost or gained. Just what charge a main group element will obtain when it becomes an ion. So, for metals, the thing to remember is that the charge is equal to the group number. Right? Just like over here, right? Lithium is a metal in group 1A, right? It gets a charge of +1. Group 1, 1 charge, right? For nonmetals, the charge is equal to the group number minus 8. Let's take a look at this image to see what I mean. Right? This is a cut down periodic table that shows you the metals on the left hand side and the non-metals on the right hand side. It shows you how in group 1A the charge that those atoms obtain when they become ions is +1. In group 2A, magnesium, calcium, strontium, their charge when they become an ion is +2, 2+, right? In group 3A, we see aluminum, right? Over in that side, that's still a metal. Aluminum is still a metal in group 3A, and when it becomes an ion, it gets a charge of 3+, right? We see that hydrogen is on top of lithium in group 1A, that first element. Hydrogen is not a metal, but it still becomes a +1 charge when it becomes an ion, so that's why it's in that group. Okay, so on the right hand side, we can see that, for instance, in the group 7A, the halogens, right, their group number is 7, so 7 minus 8 is a -1, and that's the charge for those ions. Whereas in group 5A, we see nitrogen and phosphorus, and 5 minus 8 is -3, and so we write that charge as 3- for those ions. Okay, so that does it for the introduction to ions. Thank you very much for watching.